Thank you, Leo. Thank you, everyone, for joining us today. I'm going to talk about serverless security. I will give a brief introduction about what serverless means, how it works, what are the differences between serverless architecture for web and traditional web architecture, what are the benefits in terms of security, what are the vulnerabilities that we should expect to find, and I will also see, why did it move? I didn't touch it. We will also see a mean for attacker to exploit these vulnerabilities in order to take control over the entire cloud. So let's start. This is a slide about me. My name is Yossi. I'm CEO of Komodo. We specialize in application security, penetration testing, security ratings. We've built some projects. The CTF is actually the first CTF context that was held on OWASP Israel. They are doing it now for a traditional every year. So we are kind of proud that we were the first one to do that. Hacktail is a game. It teaches the concept of digital forensics. And Spotlight is an application that monitors security events on the cloud. All are available online and they are free, so you can check it out if you want. Leo, I can't control the screen. Oh, it works now. So we see a rise in the adoption of serverless technology. A lot of our clients chooses serverless, and they actually have very good reason for doing so. For start, it is very scalable, and not only it scales easily, it's also none of your responsibility. You don't have to worry about load balancing or to worry about operation at all. All you have to do is focus on your code and build your application logic. And on top of that, it is less expensive than any other solution that are available today. So I think it's no surprise that we see a rise of adopting this technology, and I believe we will see a lot of it in the future. So what does it mean, serverless? Of course, it does not mean that there are no servers. What it means is that we do not have control over the server. We cannot SSH into the server. What we can do is we write our code and we can deploy the code to the server. The following diagram that we now see is a typical web architecture of web application of serverless. And we can build other type of application. It doesn't have to be web, but I will focus on web because I believe it is more common and also more relevant for this meeting as we speak about security. So I'll cover this component in a second, but I first want to focus on the Lambda, on the middle orange square. This is the code that we deploy to the server. So what does it mean, Lambda? How does it work? So for start, it has no persistency. The entire environment of our Lambda is being destroyed when the execution of our code is completed. The code that we write is does not run inside an application server. There's no application server that manages our code. So what we do have is we have the ability to define event, all sorts of events that would trigger our code. So we can, for instance, choose an event of new file that was created on a specific bucket. And once the file is created, we would get a trigger and our code would start running. We can define an event based on SNS topic that was sent or whatever. Since we are dealing with web, we will obviously choose the event of invocation of REST API. HTTP request. This is the the trigger for our code. So what would happen is that we would receive, our code would receive an event object. The event object is it is built with the JSON format, and it holds all the information that we need. It holds the information of the HTTP request, the headers, the URL, the parameters, and everything that we need in order to run our code, to do whatever it is that the application does. We will generally reply with JSON string that will go all the way back to the client. Our code is also isolated. It runs inside a sandbox, and we have very limited access to the OS host. We actually have some type of hard drive access, which may provide us with some type of persistency if we will try to play with it. I'm not going to talk about this now, but for the most part, our code runs in a very isolated environment and without any access to the OS host. So if you go back to the diagram, we'll just cover other components. I hope you see my mouse. So I'm pointing on the API gateway, which functions as a web server. This is where all the HTTP requests are being handled and where we define the REST API. The bucket is where we would hold all static data, HTML files, JavaScript, media files, and so forth. On the right, we have Amazon DynamoDB. This is just an example to emphasize that most, if not all, applications would have to connect to some backend service on the cloud. Even though they run in an isolated mode, they need to get out of this isolation, out of this sandbox, and have permission in the cloud. And we will see why it is so important later on. Cognito also is an example. Doesn't have to be Cognito. Cognito is the service of Amazon. We see a client that use Keycloak or Okta or other solutions, but authentication and managing user management would almost always be outside of our application. It will be in an external server. The way that we configure such servers may also impact the security of our application. So I said at the beginning that there are some advantages. Let's try to see what they are. For start, I think everyone that was ever involved with doing penetration testing know that it can be fun, and that the real fun begins when you find a way to upload a web shell. Many, if not all, but many of the red team operation that we took started with finding a web shell, and I just cannot stress enough how important it is that this architecture just does not allow any web shell. It just doesn't work this way. So this is one serious improvement over traditional architecture. Now, we don't have web shell, but what about reverse shell? I mean, suppose we have a code execution vulnerability in our application. We have an RCE. It can be caused by so many different vulnerabilities. It can be because we use unsafe library, we use unsafe eval, XXE, whatever. So many different ways for developers to provide us with the code execution. What would we be able to do? I mean, can we do reverse shell? So the quick answer is yes, we can, but it will actually depend on execution timeout. Because as I said at the beginning, our code is being destroyed when the execution is completed, but we cannot run forever. the code has a timeout, and the default timeout for execution is 3 seconds. It is true that on some implementation, we will see developer change these default settings, and it may be even 60 seconds or even more, but really not. I would really wouldn't expect to find such settings on web application. If our application is meant to process files or do some heavy processing, then we definitely need to change this execution timeout. But on web, 3 seconds is probably what we will get, and just there's not enough. It is not enough. We tried several times, and we see the connection, and it's immediately being disconnected, and it's just not feasible to perform any reversal with this configuration. Maybe you think about SSRF now. SSRF is an old-timer vulnerability. Wasn't very popular in the past, but it gained a lot of popularity once people start moving to the cloud, since clouds provide us with a service that is called instance metadata. And if we have an SSRF vulnerability, we can get our application to call this instance metadata. And the instance metadata holds in credentials that we can use in order to extract leverage our attack and gain access to different services in the client. We may even get admin level access in the cloud. I guess most, if not all of you, heard about the Capital One attack. So that was originated by such vulnerability. But apparently, it just does not work the same way when we use serverless. Our Lambda and all the serverless architecture does run, the underlying server is an EC2 server, but our Lambda does not have access to the instance metadata of the underlying EC2 server. And it has some different equivalent service, but it just does not work the same way. And in order for us to get credentials out of it, we would need a weird situation where the vulnerability allows us to get information about internal HTTP header. I would also not consider it very, this is something that I personally never saw, and I don't think that it is feasible. So we shouldn't trust on that in order to gain to get out of the isolated environment that we have. So it seems like we hit a dead end. I mean, we have a vulnerable application. We have an code execution vulnerability, but I don't know how we can exploit it and get the fun to start. So so basically, of course, it's not a dead end. If we must know that all other application level vulnerability apply the same way. XXS work the same way. If there are problems with authentication or authorization, these are type of vulnerability that we do see quite a lot. It works the same way. We get a SQL injection. We can extract all the data from the database. Writing bad code is always bad practice, and no architecture would help us and keep us safe from bad code. But this is not what we want. We want to get out of the application. We want to get into the server. We want to get to the cloud and start, start moving around and see what we can get else. So what we did is we build a lab, and we start to play with the serverless in our lab. We changed the execution timeout so we could so it wouldn't get disconnected so quickly. And we started to play along. What we've seen is that what we really want is the environment variables. Developer, when they choose, when they do develop their code, many times they use environment variables in order to store sensitive information that may include a password for database, the location of the database, the location and password for other internal services. So this is critical information that is stored in the environment variable. But even more important, AWS itself store sensitive credentials in the environment variables. So this is a screenshot of some serverless application that we wrote, and we can see that there is the AWS session token, there is the access key, the secret access ID. So everything that we need in order to connect to the cloud and gain the same level of access that the application has. And if you remember, when I explained before, the application might need access to different services. It might need access to write access or read access to buckets. It might need access to the DynamoDB, to RDS, to other services. So whatever the application has, it's in here. And of course, if the settings are not secure enough, we can exploit it and perform elevation of privileges and get admin access. So this is all fun, but it's in a lab. But what we actually needed is a way to get it and to get all this information in one command, because we couldn't have an interactive shell. We could not get a reverse shell that would allow us to type commands. So we build this one-liner, which says, actually politely ask the server to send, it spikes the environment variables into the TCP request that it sends. And we got all the information that we wanted on one line, less than 3 seconds. It was very, very quickly done. And it was disconnected immediately. We didn't care anymore. And we got all the information that we needed. And now we have AWS credentials. We are out of the application, and we can start playing with tools like Parkour or whatever to connect to the cloud and continue from there. So the conclusion is that serverless does provide some improved security over traditional web architecture. It does not cure all. We should always make sure that the developer write secure code. And there is also importance of keeping configuration of the application intact, because if for instance, someone, instead of allowing access to specific bucket, would give the default all S3 bucket, then you might find that it will be very critical if there are other vulnerabilities in your application. So this is it. I actually thought that it would take a little longer, but I kept on time. So thank you, and I'd like to answer any question if there are any.
Okay, thank you very much, Yossi.
Okay.
Really great lecture. Guys, please write your questions in the chat or the QA. And okay, so let me read a couple of questions. Okay, so generally, yes, we will upload everything to the Meetup website, all the presentation and the recording session, of course. That will be great. Okay, so Yossi, there's a question from Yoli. Sometimes AWS Cognito user token can also be used to get access to bucket. Are you familiar with that? Do you have any insight that you can say about that? How to secure it?
Okay,
The
yes.
AWS Cognito user.
Yes, AWS Cognito is a service of AWS. By default, well, I don't know if it's by default or not, but when you, it actually works that all the database of users, and these users may or may not have permission in the AWS infrastructure. So you can build, and many applications are built the way that their users are managed in incognito, and they have no permission and no ability to connect to the cloud whatsoever, not to a bucket, not to anything. It really depends on configuration, and you can integrate Cognito users with AWS, and sometimes it makes sense, but in web architecture, I wouldn't think it's always I mean, so you can do it. It's just meaning a matter of Cognito settings.
Okay, so it's what you're saying, Yossi. It's based on the configuration.
Yes.
And it's, when you're uploading your code to an AWS, or doesn't matter which cloud environment, there is an RNR. So you need to understand what is, from security point of view, what is your responsibility and what is the cloud service provider responsibility. So when you're deploying a code on the environment, you need to understand that actually the code is in your responsibility. However, the infrastructure in some ways, and it's depend on the RNR between the cloud provider, sometimes it's on you. So I don't know if serverless, Yossi, the infrastructure, I think it's the cloud provider, but you do need to integrate to their service in a secure way. So it should be based, for example, in AWS Cognito, it should be based on AWS Cognito best practices.
It really depends. It depends on your needs and what you want to achieve from Cognito. Cognito is just one option. You can. It's easy if you are using AWS infrastructure to choose Cognito because it integrates so well. But I said you can use Keycloak. You can use other solutions, and other solution does not have any ability to integrate into AWS, and then you will have absolutely different user base, which are only have permissions on your application level. So if this is what you want, if you want to manage application level users, you can do it with Cognito as well. If you want your user to be able to connect to buckets or to other resources, I think it's Cognito is the only way. At least, maybe you can do you can do that with all, but the integration will be a little more complicated.
Okay, so another question is from someone anonymous. Are lambdas expose new vulnerabilities in comparison to other implementation, like EC2 and others?
I'm not aware of new vulnerabilities that are related to Lambda only. The way I see, the way I know, it does provide some level of protection. It's more difficult to find vulnerability and to exploit them in this architecture.
Okay. Guys, any further questions? Do you have any questions to Yossi? Please write them down If not, let's see, wait. Okay, guys, I can see that there is no further questions. So, Yossi, I want to thank you very much for your presentation, a very technical one. I hope people understood it. Just the example that Yossi presented was from AWS, okay? But I think also other cloud service provider has their own Lambda function, okay? So take it into consideration. Thank you very much, Yossi.